Most people think that making dungeons similar to your favorite game requires advanced degree in mathematics. Needing to know advanced algorithms like A-star finding, grid subdivision, etc. etc. And yes, it is true that there are many algorithms using which you can make your procedural dungeons. However, most of them have a very steep learning curve. So what if I tell you that there exists a algorithm that is super small and is used by tons of games like Terraria, Minecraft and Nuclear Throne to create their dungeons and caves. This magical method is called the random walker algorithm. And in this video, I will teach you how to implement that very same method from scratch for your dungeon generation system. So let us first start with the logic and then implement that very same logic in Godot. The walker algorithm essentially tries to mimic the walk of a person on an empty grid, marking the spaces the person has walked on as the dungeon's floors and the remaining spaces as the dungeon's walls. To go into a more detail, let us assume that our world is represented by this 10 by 10 grid. And our walker is initially present at its center, and this walker can walk in any direction, which is up, down, left and right. After every step this walker takes, it changes its direction randomly for the next step, essentially creating a snake-like path if you can imagine from the screen. This process is repeated till the time the walker has not exhausted his maximum allowed steps. Okay, up until now, we only have a snake-like tunnel in the name of our dungeon. Our dungeon still needs those wide areas or rooms to give it that fuller look. For that, what we do is that at random intervals, we create a room at the current position of our walker. For example, let us say that at every 20th step, we will clear out a 3 by 3 area around our walker, meaning that we will create a room at every 20th step the walker takes, essentially creating our dungeon. Now the beauty of the walker algorithm is that since it is so basic, it is infinitely customizable for your particular game. Two very common modifications that people do to the base algorithm is to firstly manage a floor ratio. That is, not only are we counting our steps to not exceed the maximum threshold, but also that the number of floors we have created is less than a certain ratio out of our total grid cell. For example, a floor ratio of 0.2 will mean that the total floor count must never exceed more than 20% of the total grid space. Secondly, the chance of the room's creation. Earlier I said that we will create a room at every 20th step. That is fine and all. However, what we usually do is that we allow for room's creation at every step. However, we mask it behind a set percent chance. For example, every step has a 3% chance to create a room. And thirdly, as per your wish. As I said before, this algorithm is very customizable. Go wild with it and let your dungeons follow your heart. Speaking of heart, there are two modifications that I personally like and will be adding them in my implementation today as a bonus feature, so as to not hinder the vanilla implementation of the algorithm. First of these bonuses is to let the walker have some inertia. The vanilla walker, for my taste, can take lots of turns very quickly, which leads to the creation of very chaotic dungeons. So what I like to do is to let it have some inertia and go along a particular direction for X number of steps before taking a turn, and only creating rooms in those set turns. And this leads to a well balance of chaos and order in my dungeons, in my opinion. And lastly, I like to remove dead ends in my dungeon, because honestly I feel like that they are a huge waste of time and energy and actively makes the player not want to play your game. And yeah, that is it for the logic. Now let us start with the implementation. Firstly, here is our initial setup. We have an empty level with a tile map layer containing two tile sets, with each having a single sprite. The first tile set having our floors sprite has the ID 0, and the second tile set containing our walls sprite has ID 1. These IDs are important as we will use them to fill out our world, hence I am putting emphasis on them. Enough yapping, now let us jump onto our dungeon generation code. We firstly define what a cell in our grid will be. That is, our cell will be a type enum having values wall and floor. Next, we define 4 variables. The first 2 are the width and height of our grid. Now each entry or rather cell in this grid refers to a tile in the actual game. Since I am using 64 by 64 tile, multiply both of these numbers by 64 to get the actual size of the grid with respect to pixel count. Next, we define the max steps our walker can take, which I like to scale off of my grid size. And typically you would want to keep it a higher count for more variety, so this formula kind of works for my case. Next is the floor ratio, 0.3, meaning that up to 30% of the grid can be a floor. Next, we define 2 variables for the room. One is the room chance, that is, every step has a 0.05% of chance to be turned into a room, and secondly, the room radius, that is a space around the walker we will carve out for the room. Next is the variable for seed value, which will be used later on for randomization, then an array for our 4 cardinal directions, then our empty grid, which we will initialize later on. And finally, for the variables, we will define our walker class, which will hold our position and the number of steps that we have taken. Now let us start the actual logic. Create a function called generate. This function will return to us an array that will be our final dungeon plan, which we will flesh out with our tile maps in our levels code. Now let us write the function to initialize our grid, which is nothing. We just resize our grid to the height and width defined above and mark all the cells as walled. And similarly, now we initialize our walker, which will start at the middle of the map, having its initial permissible number of steps as a maximum threshold. We create our target floor count variable using the floor ratio, and then the actual floor count variable, which we will increment. Now let us start our initial step by firstly picking up our initial direction and then defining our inertia. That is, I want the walker to walk at least 2 to 4 steps before changing its direction. For the vanilla implementation, just change this value to 1 instead of this random range. We then enter our loop, which we run until we end our step count or our floor count exceeds our target. At every iteration, we mark the current cell as a floor and increment our floor count. If our inertia or the steps until turn has exhausted, that is, it is time to turn, we firstly try to create a room, we then change our direction and rebuild our inertia. The logic to carve the room is pretty simple. We just go around our position in a 2 by 2 grid and mark all of the cells as a floor. We then take preparations for our next step by firstly checking that whether it lies within our grid or not. If we lie within the grid, we take our next step. If not, then we have to change our direction. And to check whether a position lies within the grid or not, we just check that whether it lies within the extremities of both the horizontal and vertical direction. With this, our dungeon plan is done and we return the grid out. The grid now contains a combination of both floors and cells. However, it will have some dead ends, and to clean those dead ends, we write this function. A dead end is nothing but a floor that leads to nothing at the end of a long tunnel. That is, it is a floor surrounded by walls on 3 sides. So to remove such dead ends, what we do is we loop through our grid, count the number of floors neighboring our current one, and delete that cell if the number of neighbors is less than equal to 1. With this, our plan now is finally ready. Now let us flesh it out by giving it the required tiles in our level. Go to our level scene code and make references to both the tile map and the dungeon generator, then variables for our 2 tileset IDs. In our ready function, we firstly get our dungeon's plan and then apply the tile map to it. To apply our tiles, we loop through this grid plan, and if our current cell is of type floor, we instantiate a floor tile on the game scene, and similarly so for our wall. And with this, we are done. Let me demo it out for you. And as you can see, the dungeons look pretty good in my opinion. So yeah, that is it for today. Hope you guys liked today's video. Be sure to like and subscribe and comment to boost the algorithm. And I will catch you guys the next time.